Welcome back. I'm Shivaji and I'm helping you to learn pointers in C. We have learned the definition of pointers in the earlier tutorials, and we can now declare a pointer and can dereference a variable using a pointer. In this section, I'm going to talk about the address arithmetic with the pointers. That means what happens when we apply the addition and subtraction operations with the pointers, how the pointer is going to be evaluated in such cases. For your information, we cannot apply the multiplication and division operations with the pointers. That's not allowed. But addition and subtractions can be done with the pointers, and we need to see how they are actually evaluated. Here in this example, we have a variable x that is initialized with 10, and we have a pointer p, and we have assigned the address of x to the pointer p. So p is right now pointing to x. We can just draw a block diagram in order to understand this situation. So x is a variable that is contained with 10, and I'm considering that 67110 is the address of x. That's obviously, I'm guessing, not practical, but it will help us to understand the situation. Okay, so p is the pointer and p contains the address of x that has been assigned to p. So p contains 67110. So p is right now pointing to x. That means if I derefer p, I'll get 10. Now here I have printed the content of p, and then I have incremented p by 1. Then I have printed the content of p again. Now what will happen with this statement? That means if I try to add 1 with the pointer, then what's the value that the pointer is going to get, or how it is going to be evaluated? Actually, when we add 1 with integer, it's always the next integer in the integer domain. That means if I have 100 as integer number and I go on and add 1, then always I get 100 and 101, because 101 is the next value in the domain of integer. But when we are talking about address, if 6710 is the address of one integer, then the address of the next integer is always going to be 6714, because integer takes 4 bytes in the memory. So 6711 cannot be the address of another integer, because it's being occupied here. All the 4 bytes from 6710 is occupied by x. So the available address for the next possible integer is 6714. That means when we go on and add 1 with integer pointer, it's always going to be 4 bytes that is going to be added with the pointer value. So here it's going to be 4 more than the value that we had here. So in my example that I have taken here, if it is 6710 and we go on and add 1 with this p, it should be 6714. Had p been declared as double pointer, then adding 1 would actually increase the value of pointer by 8, because double variables takes 8 bytes in the memory. So if it is float pointer, then 4 would be added. Okay, let's just run the program and see what happens, whether it is just giving exactly according to our understanding or not. I'm running this. Here you can see that the content of p earlier was 3928, and then it was 3934 added with 3928, and everything remains same. Actually, I'm just considering last 4 digits. So it's 3928, and then it was increased by 4, and it is 3932. Similarly, if we subtract 1 from integer pointer, then 4 bytes will be decremented, and if it is a double pointer, then 8 bytes is going to be decremented. So the simple formula is that, so if we go on and add 5 with integer pointer, then actually it is 5 multiplied with 4, that's 20 bytes will be added, will be forwarded. The pointer is going to be forwarded by 20 bytes. So if I subtract 5, then the pointer is going to be subtracted with 20. Okay, so that's pretty simple. So therefore, if I just generalize this with a constant c, that means if we apply this address arithmetic, then the formula for address arithmetic is something like this. It's the current content of the pointer. So the current content, then plus, if c is the constant that we are adding, multiplied with size of type, the type that the pointer is dereferencing. That means if it is integer pointer, then size of integer. If it is double pointer, then size of double. So you can consider that this is p. Right now it is 3229, something like that, and then c is 1, then multiplied with size of integer 4, so it's going to be 3233, or it is, if it is 3228, then it is 3232 after this operation. Similar with the subtraction, then the 4 bytes are going to be subtracted. So if the value of C is 2, then 2 multiplied with 4, it's 8. So 8 will be added with the current content. Similar with the subtraction. So that's how the pointer arithmetic takes place. Now I would like to give you one question here, and that's interesting. Let me just go on and remove this. So we have a double pointer P, and that is initialized with something like this. And we are having another double pointer, say Q, and we are initializing this with, say, 2000. Now I'm just going and printing this. So what I'm doing here, I'm printing P minus Q. Can you guess what's going to be the output in this case? I'm just giving you the block diagram again that will help you to evaluate this. Now P is pointing to the location 1000 of the memory, and we just cannot directly assign this integer number to a pointer variable. The compiler is going to flag warning in that case. I'm just explicitly casting this and telling the compiler that yes, I know that what I'm doing. I'm converting integer to double pointer in my own discretion. Okay, so you do that for me. So here's the 10,000 byte, say, and the pointer P is pointing to this, and pointer Q is pointing to the 2000 byte of the memory. So this is the 2000 byte of the memory. So Q is pointing to this, and we are not subtracting star P minus star Q. That means we are not interested about the content of these locations. We have not mentioned star P or something like that. We have not dereferenced. We have only subtracted Q from P. That means a pointer subtraction is going to be performed here. Now what's going to be the output if I do this? It's pretty simple. If I subtract one pointer to another, that means I am trying to find out how many locations between them. So since both of them are double pointer, then in this case the compiler is going to evaluate how many double locations are available between 1000 and between 10,000 and 2000. So it's going to be 10,000 minus 2000 divided by 8, because 8 is the size of each double value that that's there in the memory. So it is going to be 1000. That means 8000 divided by 8, that's 1000. That means we can have 1000 double values between 10,000 location and 2000 location. So that's the meaning of this. If we go on and subtracting P minus Q from P, then it means that how many double locations could be there between P and Q. So in other words, we can just go in this way. If we go on and add 1 with Q, then it's going to be 2008, because Q is double pointer. So P minus Q means what should be added with Q in order to get P. So if I add 1, we get 2008. If I add 2, we get 2016. So if we add 1000 with Q, that means 2000 plus 1000 multiplied with 8, that's 8000 plus 2000, that's 10,000. So P minus Q is 8000. That means 8000 locations between, double locations between P and Q. So here it is. If I run this, it's going to be 1000, as we have understood from the discussion. Let me show you that. Okay, here it is 1000. Thank you.